Random forest. This section is to introduce random forests. So far, we have learned the machine learning models that learn a single hypothesis chosen from a hypothesis space that is used to make predictions. To enhance the performance, we could build multiple models with ensemble learning. Ensemble learning is to select a collection of hypotheses and combine their predictions in order to reduce the error rate. For example, you can build 100 different decision trees from the same or different training sets and have them vote on the best classification for a testing sample. This figure presents an example on how the ensemble learning works. You can build M subsets on the training data, then train M learners on these subsets to obtain M models. Finally, you can combine the predictions from these M models with majority voting. Let's take weather forecasting as an example. We have 5 forecasting results with 5 rows, where each row is a forecasting from one learner. The reality is the ground truth. You can observe that the combined forecasting with majority voting is much better than each individual forecasting. Bagging learning is a basic category of ensemble learning. It is to train M learners on M bootstrap samples and combine outputs by voting. The right side shows the algorithm. It can decrease error by decreasing the variance in the results due to unstable learners. Instead of building different subsets by sampling on training data, as in bagging, we can reweigh examples in the training data to build these subsets. At each iteration, a new hypothesis is learned, and the samples are reweighed to focus the system on examples that the most recently learned classifier got wrong. Finally, we complete classification based on weighted vote of weak classifiers, where the weights of weak classifiers are measured based on the performance on training data. The right figure shows you how to obtain the weight for weak learners. You can see the more accurate the performance of weak learner is, the bigger the tree is, where size of decision tree indicates the weight of that hypothesis in the final ensemble. Random forest is a standard ensemble learning model, where the weak learner can be different decision trees. It is to build multiple decision trees at training time and output the class that is the mode of the classes or mean prediction of the individual trees. The main benefit is that it generates an internal unbiased estimate of the generalization error as the forest building progresses. We can apply bagging learning to build tree learners. It will repeatedly select a random sample with replacement of the training set and fit trees on these samples to build N decision trees, shown on the right side. After training, predictions for unseen samples X can be made by averaging the predictions or by making the majority voting in the case of classification trees for the final result. Generally speaking, random forest is more robust and faster to train. In addition, it can handle missing or partial data and is easier to extend to online version. However, feature selection process is not explicit compared to decision trees. Feature fusion is also less obvious. Usually, it cannot perform well on small size of training data. Thank you.